All right. Hello and welcome everybody to Aviatrix Demo Day. I'm really excited to have you all join us. We have a good group of people, still have people trickling in, but this will be recorded. So if you miss anything from the beginning, you can go back and watch the recording. So I want to give a little bit of a background on what Demo Day is all about and why it came about. Aviatrix hosts multiple events every week. We have quite a few of them. We have tech talks, we have webinars, we have partner webinars. We have quite a bit of events happening every week. And from every event, we have people asking us, organizations asking for demos. They want to see the solution in action. And it's hard to scale that out to have hundreds and hundreds of people asking you for demos. And so what I did is actually built a recording of deploying a comprehensive multi-cloud network with a bunch of our bells and whistles integrated. And the video is edited and sped up in some pieces, so we don't have to wait for things to be deployed, but you all will be watching this live with me. Now, before we get started, if you want to see other Aviatrix events, please go to aviatrix.com/events, and they're all here. You can see pre-recorded ones, you can see what's coming up, you can sign up and get involved with everything that we're doing here in the multi-cloud world. With that said, let's get started. So I'm going to give you guys a baseline as to what we're going to build today together. And so I'm going to bring up these diagrams here. I have kind of these lucid charts that I've built out that will show you step by step what we're doing together in the UI and with automation, okay? Now, I'm gonna just fast forward right to the end because what you're gonna see here, this is what we're gonna build out, okay? In the end, we're gonna have these two AWS transit environments in two different regions in Europe, and we'll have an Azure transit environment in the US West. They will all be connected to each other via a full mesh architecture. It looks like they're back-to-back connected, but it's a full mesh. It's just I couldn't show that on the diagram cleanly. And then we'll have spokes connected to each one of these transit environments. We'll also have a connection back down to on-prem via a site-to-cloud VPN tunnel. Okay, we'll talk more about what this is and how it's being deployed, but we wanted to have some on-prem connectivity there. On top of that, we're going to enable segmentation. So Aviatrix has our own method of segmentation in the cloud that supports cross-cloud or multi-cloud segmentation policy. And we're going to do that as well. When we get to that point, we'll talk more about it. And lastly, I'm going to demonstrate some of the visibility and some of the troubleshooting tools that we have built in for day two. So after we build all of this out, we need some way to manage it and monitor it and troubleshoot the overlay and the underlay and have all that visibility for us, okay? So let's get started. The first thing we're going to do together is build out via the UI the Azure US West transit environment, and then we're going to connect one of my Azure workload VNets to that transit environment. So let's get started. I'm going to move over to my video here, and I'll pause it from time to time to add commentary. Now, if you guys have any questions, please throw it in the Q&A box. We have a couple people on this call, one of my colleagues, that will be answering these questions in real time, okay? Let's get started. Here we go. So we're going to be building the Azure West Transit and the spoke via the UI. The first thing we do is we go over to the multi-cloud transit section, and under setup, we click that, and we'll start by building out the Aviatrix transit gateways in that VNet, right? Very straightforward. It's just a bunch of drop-down boxes. You select the cloud type. We're going to select Azure, of course. We'll give the gateway a name. Let's just give it some name here. Azure, I think I called it Azure West Transit. Yep. And then we'll select the account. Keep in mind that the Aviatrix controller is a multi-account, multi-subscription. So you can onboard many accounts and subscriptions and manage it all from one UI. We select the region. It will then pull the resources in that region to see what you have out there, what resource groups, what subnets. And so we're going to pick a predefined VNet that I've created in it, earlier on. It's called the West Transit. And then I'll select one of these public subnets to put my gateways in there. You can select the gateway size and a bunch of advanced options if you want to do that. But really, the defaults are pretty good. You just hit the create button. Now, I fast forwarded this, right? It's actually would take a minute or two, but this is only taking a couple seconds. Behind the scenes, what this is doing is pushing, 20, 30, 40 different API calls and configuring the gateways and installing them in that VNet. It's configuring UDRs, it's adding network security groups, it's doing anything that's related to networking in that construct or in that cloud and building it out for you. You would have to do all that manually. You have to configure IPsec tunnels and routing and security policies, but Aviatrix is going to do all that for you. All right, so we're done, successful. I like how they add a little congratulations there that the coders think they're funny. And then we're going to continue on and we're going to make this HA. So HA just means we're going to spin up a second gateway right next to the primary gateway we just created, and it will configure everything to be HA. So you have active, equal cost multipath routing and high throughput and resiliency. So it's as simple as selecting the gateway and the alternate subnet. All right, so you have this set up in multiple availability zones. All right, so that's going to go through that. It's pretty quick because I've fast forwarded it. All done. All right, now we have 2 gateways up and running in that transit VNet. So that transit VNet is actually ready to start to take on spokes. But we're going to first validate what we built out. So we click the list button, and then under the transit tab, we can go and search for the Azure gateways that I built out. So I just search Azure, and you can see here we have the Azure gateway that it created, but then we also have that HA gateway that it created for us, and it appended HAGW, so you know that it's the HA gateway. You can see the VP CIDR that's been configured for it. Let's go back, and the next step now is to put gateways into the spoke. That's where my workloads live. So I'm going to scroll down to step number 4. This is a workflow with guardrails. It's really hard to make a mistake because, well, it's actually impossible to make a mistake. And if you did, it just backs you out and says, hey, you got to do this first. So it's hard to make any mistakes while you're building things out with Aviatrix. Okay, so we're going to launch spoke gateways where our workloads live so we can eventually connect that spoke to my transit. So it's the same process. Pick the cloud type, give it a name, click the account, select the region. It'll parse the region for the resource groups and the subnet that you have built out. You're going to select that. And same thing, leave everything default unless you want to make some changes to our configuration, and hit create. Same process, behind the scenes, multiple API calls to configure everything from routing to security to get these gateways in place and to bring them up. So we're building the primary gateway. All right, so we're going to scroll down after that is done, and we'll make it HA as well because we want active, load balancing and resiliency across the transit and our spokes. So you select the spoke VNet, and then you will select the alternate subnet to build the gateway out in. Same process. It does its thing. You sit there and have a coffee while it's finishing everything for you. It's spinning up the gateways, configuring routing and security, the IPsec tunnels. Great. All done. Very easy. Well, what's the next step here? Let's validate that we built out those spokes correctly. So you go back to list, click the spoke tab, and we're going to search for my Azure spokes. I'm just going to type Azure in there as a keyword, and you can see I have some Azure spokes deployed. See Azure West Spoke Gateway and Azure West Spoke Gateway HA Gateway. We can also see the CIDRs that were attached to that. Next step is to connect those spokes to the transit, right? Pretty straightforward. Step 6A, attach spoke gateway to transit network. You select the gateway that you want to connect, and it'll automatically connect the HA gateway for you as well. It makes some assumptions here. It says if you're going to connect the primary, you're going to have to connect the HA one as well. So you only have to select the primary, and then you select the gateway, which is the transit, which is the Azure transit, and hit attach. All right, it's running through that. It's connecting the transit to the spoke, and what it's doing here is building equal cost multipath IPsec tunnels and configuring the routing in the VNet tables, the UDRs. It's configuring the routing in the gateways, and now it's connected. So actually, you would have IP connectivity in and out of those environments. Let's double check how it's been built out. Go back to list, click spoke, search for Azure as a keyword, and I can see here these are the gateways that I created. But if you actually scroll over the transit gateway section, you can see which transit gateway I connected it to, right? We're validating that connectivity is in place. All right, awesome. Okay, so let's go back to what we built out. So what we did was we configured this VNet with 2 gateways in there, and they're active, and then we configured 2 gateways in the workload VNet, and then we created the equal cost multipath IPsec peering between the two. All right, and all the routing was done for us. Pretty brilliant, right? That took minutes, you know, and everything was configured and ready for you. All right, what's next? Let's scroll down and take a look at what we're going to build next. So what we're going to do is build out the AWS environment, right? This is going to become a multi-cloud environment. So we're going to do AWS as well. And I'm going to configure 2 new transits in AWS in 2 different regions, one in EU West 1 and another transit in EU West 2. I'm going to, of course, connect those 2 transits together, but we're going to take this a little bit step further. We're going to also instantiate firewalls in these transits. So this is going to become what's called a FireNet transit. And we're going to insert these firewalls into the path of traffic. It's going to automatically spin up the firewalls. It's going to configure the life cycle of them. You could even push the bootstrap config file from Aviatrix controller into those firewalls so that they're ready to go and ready to start routing and forwarding traffic. However, that's not part of this demo, but the spin up of the firewalls you'll see is. Okay, and then I will manually configure and connect the AWS environment to the Azure environment. Now, the interesting thing about this section of the video is that I'm doing all of this via Terraform. This is automation. All right, this is a declarative automation code language that's super simple to pick up. Anybody can pick it up and figure it out. I mean, I'm not a coder, but I spent like an hour with one of my colleagues. He explained it to me and then I just ran with it. And now I'm building things with Terraform. It's pretty brilliant. And you can automate and you can spin things up and grow it out horizontally really quickly. Okay, so through Terraform, I'm going to show you the code and how I built it out. And then we'll run the Terraform script. Okay, so let's go back to the video. So you can see here, build AWS FireNet transits and peering via Terraform. So here's my Terraform code. And actually, I built it out via modules. Terraform modules are kind of like a shortcut. Behind the module, within the module are actually a bunch of source code. It's referencing another environment where there's source code that has all the variables and options for like what type of firewall you want to build out, which like subnets you want to put it in, all that stuff. All that's there. But one of my colleagues built these modules out. And these are publicly available. So all you have to do is grab the modules and fill out the information like the CIDR, the region, the account name, and then the firewall image type. So you can see here, there's 2 different FireNet domains I'm building out in AWS, one in EU West 1 and one in EU West 2. And then beneath that, I have a resource call out. And that resource is just saying, hey, take whatever you built out in Transit Gateway 1 in EU West 1, and then whatever you built out in EU West 2 and connect them to each other via an Aviatrix encrypted peering. It's as simple as that. It's a very declarative configuration or declarative language. You can see here some of the variables that I'm referencing. And actually these variables are going to be inputted into Terraform Cloud, which is kind of like a UI mechanism. It's a UI for deploying Terraform. You can deploy all this via CLI. I'm a UI guy, and I'm not going to lie. And so I like to leverage the UI. And Terraform has an amazing thing called Terraform Cloud, which I'll show you. Here's the source code of those modules. It's very straightforward. There's nothing in here that's cryptic. You go through and it shows you exactly what you need to pop in here as your variables and values to get it to deploy correctly. And if you want to know more about what each of these lines means and how to configure them, you can go to the official Terraform website, terraform.io, and go to our Aviatrix provider documentation page, because we're an official provider. And then you can see all the docs and how it's deployed and how you can leverage these different modules and resources. Very straightforward. Anybody can pick this up. You don't need to have any coding experience. All right. So this is Terraform Cloud. This is it's a free tool you can leverage to input your Terraform code in here, and then you can just have it run it from this environment. You don't have to have a CLI built out in your computer to run it. You just run it from Terraform Cloud. So we're going to queue it up for deployment. You just go there and type the queue name. Okay. And it's going to check it. It's going to check all my code to make sure it was configured correctly, and it's going to do what I expect it to do. So you can see here, It's planning to deploy 11 resources, 11 things in my environment, 11 modules, 11 components. And you can actually go through and see what it's doing, right? You can go see exactly what it's going to deploy. I'm ready to deploy it, okay? All I gotta do is go down to the confirm and apply and give it some comment. Let's go. Let's do this, hit confirm plan. All right, now it's running through. It's pushing all the APIs to deploy this. Now I've sped this up, of course. This took about, I think, maybe 10 minutes or so in the real world. But in my demo, it's going to be done momentarily. Done. See, apply complete. It successfully built 11 things, 11 resources, okay? So let's go validate what it built out in the UI. So to do that, first thing we're gonna do is go to the list. Remember, this is how we can see what was deployed from a gateway perspective. And I'm going to search anything to do with EU, the Europe, because that's what I built out. There we go. 4 gateways were built out. Remember, we have 2 transit environments, one in each EU region, and we have 2 gateways in each one of those. The active and the, well, they're both active, but the HA gateway is there as well. So that's 4 total. And you can see the CIDRs that it picked, or that I picked when I was building it out. And you can also see that it connected these 2 transits together. TGEU West 1 is connected to TGEU West 2. Those are the 2 transit AWS networks, okay? That's an encrypted IPsec high throughput peering between the 2 transit networks. Now we're gonna see the firewalls. So under the firewall section, under setup, if we scroll down, you can see the firewalls that I built out. There's 4 Fortinet FortiGate firewalls, 2 in each transit environment. It did everything for you. It spun them up, it grabbed them from the marketplace. It put them into the path of traffic. It configured the routing, right? You can even download the PEM file from here so that you can access the Fortinet firewall via CLI and do stuff. And you could have also pushed the configuration file if you wanted as well. I didn't do it in this demo, but you could have done that so you don't have to do anything. It would have been 0 touch. But I'm just showing you that you can click the UI link and it'll take you directly to the UI of the Fortinet. That took 10 minutes to deploy 4 Fortinets, do all the configuration, all the routing, put them in the path of traffic. Incredible. It's really amazing what Terraform can do for you and what Aviatrix can assist you to deploy. All right, I'm going through the advanced section now to tell you to kind of look deeper into how the firewalls were connected. You can see in EU West Region 2, I have these 2 gateways and I have 2 firewall instances connected to those gateways, and EU West 1, the same thing. You can also see that inspection and egress is enabled. Inspection means that I can now forward the traffic from certain VPCs based on a policy to this firewall cluster to get inspected. And I can also inspect traffic as it egresses to the internet, right? So what that egress has done is it's enabled a default route propagation within my environment. So now a default route is going to be sent to my host VPCs, and they will be forwarding their internet traffic towards this centralized internet egress where you have these next generation firewalls to do your inspection. Brilliant. I love that feature. I love just playing with it every day. It's just a fun thing to mess with. All right. Next thing we're going to do is we're going to spin up gateways in my EU West 1 and EU West 2 workload VPCs. So I have some workload VPCs where the apps live, and I'm going to throw some gateways in there and connect them to their appropriate transit environment, all right? So EU West 1 is going to connect to the EU West 1 transit, and EU West 2 workload VPC is going to connect to the EU West 2 transit environment. And we're going to do that via the UI. And you should already be familiar with how to do this, right? Because I showed you how to do that with Azure. It's the exact same thing with AWS. You no longer have to figure out how do I configure the differences between Azure, AWS, GCP, OCI, or any other cloud that we start to onboard. It's the same architecture, the same functionality that you stamp out over and over again simply. So anybody can deploy this. All right, so let's go and watch that. So peering. Oh, actually, before we do that, we have to peer Azure and AWS Transit together. That's this link here. I forgot to do that. So let's peer these 2 guys together. That's very simple. So we're going to hit play and we go back to the Multicloud Transit section, click Transit Peering. We're going to add a new peering. And all you have to do here is select the names of the transit environments you want to peer together. So TGEU West 1 is going to connect to the Azure environment. Okay. It's building the IPsec, it's configuring the routing for you. Great. You can see the status is unknown right now because the tunnels are coming up, but by the time we're done, the tunnels will be up. So we're going to connect the EUS2 to Azure as well. Remember, we want to create a full mesh of transits. Great. All done. And if you give it a minute and you hit the refresh button, it will come up. Bam. Nice connectivity there. End-to-end connectivity, full mesh, all the routing is done for you. We should have end-to-end connectivity at this point. We can validate this connectivity by going to the dashboard map. We can zoom in and see what peerings are up, what peerings are down, the health of the peerings. We can even see the latency, cross peering from gateway to gateway. And so you can leverage this for troubleshooting your app connectivity, your app performance. Okay. Quite a nice way to visualize that. And if it goes up or goes down, it'll tell you. All right, great. So we're gonna now, so we created this thing here, right? The peering between the Azure environment and the AWS. And remember, I told you that in this diagram, it looks like I'm only connecting West 2 to EU West 2. That's not true. I'm actually connecting both EU West 1 and 2 to Azure West 2. I just couldn't demonstrate it on the diagram cleanly, but you guys get the idea. It's a full mesh within here. Okay, so now we're gonna create the gateways in the AWS spokes and connect them back to their appropriate local transit environment. I'm gonna do this via the UI. And like I said, you should be familiar with this at this point. It's the same thing. Under Multicloud Transit, you click Setup. You scroll down to the spoke section, not the transit section. We're done with the transit. We're gonna create some spoke gateways and put them into those workload VPCs, all right? So you select the cloud type, of course, it's AWS. Give it the gateway a name, select the account type, and then the region, and it'll go into a discovery and see what you have out there. We're going to pick the VPC that I have already pre-created and a subnet that's a public subnet, and we can leave everything else pretty much default and hit create. Same process as deploying the gateways, configuring the routing, configuring the security groups, configuring the NACLs, the load balancers, whatever it needs to configure is doing that for you. All right, congrats, we're done. So we're going to now build out a gateway in the other VPC. Remember, there's two VPCs, one in EU West 1 and one in EU West 2. So we're going to put another gateway in the other guy. Same process. I just changed the locality and the name and the subnet, and it deploys it for you. And then we'll enable HA as well. Done. So let's scroll down. Let's enable HA. Pick the gateway that you want to enable HA on. Pick an alternate subnet, and actually it makes an intelligent assumption that you're going to use an alternate subnet. It's not going to pick the same one. So it picked the alternate 1-1C subnet for me already. So you just hit connect and it does it for you. You can see how quick this is to deploy your environment. It makes intelligent assumptions for you. All right, so we're going to pick AWS EU2, and we're going to put an HA gateway there as well. Deploy that. All right, what's next, guys? We got to connect the transit network to those spokes. So you pick the spoke gateway, you pick the transit environment. So EU West or EU1 is going to talk to EU1 transit. All right, doing its thing. We're going to do the same thing with EU2. We're going to connect it to the EU2 transit. We're going to click attach. Alrighty. That was easy, right? It was the same process we did with Azure. So let's go back to our diagram and see what we built out. What we built out right here was the connectivity of this EU West 1 to the EU West 1 transit, as well as the EU West 2 to the EU West 2 transit. The transit environment is already connected. We've completed all that already. So we should actually have end-to-end connectivity at this point, and we'll test that in a moment. But next, what we need to do is we want to connect the on-prem, a data center, or an Equinix facility, really anything. It could be a user, I don't care. It can be anything outside of the cloud. We want to connect that into the cloud. And so what I'm doing is I'm just picking EU West 1 as our onboarding transit environment to connect to on-prem. And this configuration or this connection can happen over the internet. It can happen over a private peering connection that can be given to you by like Megaport or Equinix or any one of those types of organizations, or it can be done over a direct connect, an express route, a cloud interconnect link. We don't care. Public, private, we can build the connectivity downstream and orchestrate it all for you. All right, so we're building this environment. On the on-prem is 1051.64.0/20. You're going to have to keep that in mind because you're going to see that subnet pop up when we start to learn about it. I'm going to do it via the UI because I like the UI, but you could do everything I'm doing now via Terraform as well. So we're going to go under the setup section and we're going to scroll past this, and there should be a section, I think it's section number 3. Yeah, connect to external devices or a VGW, whatever you're trying to do. So, but we're going to connect to an external device. Really what I've set up on the other end was a CSR. It's like a virtual router from Cisco, and it's sitting in a VPC elsewhere. It's going to demonstrate or act as if it's an on-prem environment, okay? We're going to do BGP. We want to learn BGP. We want to be able to retain the BGP intelligence and path selection and everything. So it's as simple as selecting the transit that we're going to connect to, which is West 1, give it a name, give the connection a name, select our local ASN for our local transit. And in my demo, I picked 4055. That's probably somebody's public ASN, but I probably shouldn't have picked it, but it doesn't matter because it's all internal lab. It doesn't matter, but I probably should pick some private thing. Doesn't really matter. But then downstream, I know what the CSR is expecting from the hashing algorithms and the IPsec and IKE information. So I'm going to select all that. You guys, I'm sure have seen this before. It's just like any standard IPsec build out. So I'm selecting some stuff that I know that the CSR is expecting. All right. And then if there were multiple CSRs or multiple external entities that I'm connecting to, you can enable HA and it'll create multiple tunnels for you and do equal cost multipath across them from every gateway. And if this is over a private peering or a direct connect, you can click that button there that says over direct connect. I can select my remote ASN and my remote IP I want to connect to. Again, that can be public or private depending on what I'm trying to connect to. And I can configure my pre-shared key or let it pick a really complex hash pre-shared key. I'm going to do demo day 1, 2, 3 because it's simple. And I don't have to configure the local tunnel IP and remote tunnel IP because it will do that for me automatically. All right, then you click connect, hit OK. And now it's building that IPsec connection to my transit. All done, right? Now we want to validate that that was built out. To validate it, you go under the site to cloud section of the UI and then click the setup button. And you'll see here, right there, on-prem VPN. It's built out, but it's not up yet because I haven't configured the other side of it. I'll do that behind the scenes. But what I can do is click edit, and then I can grab the configuration file. So it generates a config file so that I can go and take that and give it to my security guys or whoever's configuring the on-prem side, and they can leverage this as a guide to configure the other side of it. It gives you the BGP information, the IP addresses, the ASN, the hashing, and all that stuff that you need to build it out. So I did that on the back end. I went and did that, and I fast forward the video, and you can see now it's up. My connectivity is up. So let's validate that. Remember, there's 2 gateways here. So I'm going to create 2 tunnels, active, equal cost multipath tunnels to that downstream device. You can see they're both up here. All right. Now we're going to validate the routes that are being learned via BGP. So we go to Multicloud Transit under the Advanced Config tab. We're going to select the gateway that I'm peering with, and we can run our normal show BGP commands. We run a BGP stack, so you can do show IP BGP summary, show IP BGP, show IP BGP neighbors and events and all that stuff. All right, so hit OK on that. Oh, there we go. We can see that I'm learning from that on-prem environment, that 1051.64.0/20. I can see the AS path, the next hop, and our controller learns about it and then programs that route everywhere within the cloud that it needs to be dynamically, okay? This is a dynamic mechanism. It's a software-defined networking architecture where it will configure things dynamically for you. You can also see on the CSR that I'm learning those cloud routes, 191, 193, 194. Those are my EU1, EU2, and Azure routes. Okay, so now we have end-to-end connectivity from on-prem into the cloud. Super simple connectivity mechanism, okay? So like I mentioned, we built this out. Everybody can talk to everybody, and we're going to run a test on that. Okay, so let's run a connectivity test. So I'm going to run pings from this guy over here. I have a host sitting in the EU West 1. I'm going to try to ping EU West 2 and West US 2 in Azure. So you're going to see it's going to go across these transits to reach the different environments. Remember, it's full mesh, so it's one hop away. It's not going to go through another guy to get to Azure. It's going to be full meshed. So we'll validate that here. So I'm going to ping, I think I'm pinging the AWS environment next to me. Yeah, you can see based on my latency here that this is within Europe. Look how low the latency is. It's crossing the AWS Europe backbone to get to that other guy. Now I'm also going to go to Azure, and you can see I'm going all the way to a different continent, right? It's going from the Europe environment to the US environment. So it's 132 milliseconds, of course, because it has to cross the undersea cabling. All right, great. But now what we're going to do is we're going to enable segmentation. Aviatrix is the first to bring real simple segmentation to cloud networking and make it simple to deploy this across multiple clouds. The same policy, the same segmentation architecture across clouds. It's brilliant. So what we're going to do is we're going to create a sec domain 1 and a sec domain 2. And EU West 1 workloads are going to go into sec domain 1. EU West 2 workloads are going to go to sec domain 2. And then the Azure workloads are going to go into sec domain 1 as well. So what you can imagine is that sec domain 1 or EU West 1 and sec domain 1 is going to be able to talk to sec domain 1 West US 2 region in Azure. That will happen because they're part of the same security domain, but they're not going to be able to talk to sec domain 2 unless I allow it via policy. So let's first actually build it. It's so simple to build. You go under Multicloud Transit, under the segmentation piece, we have to first enable segmentation on our transits. So we pick our transits and you click enable. It's as simple as that. Of course, there's all sorts of logic behind the scenes that we're doing, configuration, API pushes, and all sorts of stuff to get this to work. But all you have to do is select the transit environment you want to enable segmentation on. So we're enabling it on all 3 transit environments that we built out together. The last one is Azure. Enable that. We're good to go. They're ready to support segmentation. The next step is to configure those secure domains. We have to identify them, right? So let's create the secure domain 1 and secure domain 2. Done, okay? Now, what I'm showing you here is that secure domain 1 by default is not connected to anything but its own secure domains, not connected to secure domain 2. See, it's on the non-connected pane. Later on, we'll move that and connect the 2. So let's then connect, we have to actually tell the environment which secure domains our VPCs and VNets are a part of, right? So just pause that and go back here. I'm basically telling the infrastructure that, hey, EU West 1 is a part of sec domain 1, and EU West 2 is part of sec domain 2, and West US 2 VNet is connected to sec domain 1. Okay, so let's do that. Simple as selecting the transit, select the secure domain, and then telling that transit what VNets and VPCs are a part of that secure domain. All right, so I'm doing that for you. EU1 gateway, associate it, and let's go to the other transit in Azure. He's also going to be part of sec domain 1, and we're going to pick the gateway that's connected there. Sec domain 2 is for this environment. See, select sec domain 2. Perfect. And we're all done. Okay, now I'm just validating again that sec domain 1 isn't connected to anything but itself, non-connected. So let's validate that. I should be able to ping from here all the way to here through the full mesh Aviatrix encrypted backbone, but I should not be able to ping sec domain 2. Remember earlier we were able to ping across everything. So let's go and do that now. I'm pinging that guy there across to Azure. There, you can validate that it's Azure because the latency is high, right? It's going across the undersea cabling, and I can talk to him. But I'm going to try to ping my neighbor, my Europe neighbor, and I'm not going to be able to get it, right? Look how simple that segmentation model was. Immediately, the connectivity is not there. But now I'm going to move over that sec domain 2 into the connected policies. So now sec domain 1 and sec domain 2 are connected, and the moment I go back, it starts. All the routing is reconfigured, the security is reconfigured, everything is done for you behind the scenes to connect those 2 environments. That's brilliant. You have to admit that that's incredible, because to do that manually is nearly impossible, if not impossible, within cloud and cross cloud. And to manage that at scale would be impossible. You're going to have teams and teams to manage. But now you just have this one UI or Terraform to do it all for you. It's brilliant. I love it. Okay. Now, if you didn't notice, up here, I've had some of the Aviatrix components, right? I had the controller that was in my cloud operations layer of networking. Then I had the Terraform. So I've shown you both of those things. But what I want to show you now is CoPilot. So CoPilot it's another instance. It's an analytics engine that sits next to the controller and ingests data and information from the controller, from the cloud, from your native constructs, and your gateways to gather data to give you some nice, easily digestible outputs and analytical information. So let's go look at that now. So I log into CoPilot, and the first thing you're presented with is a dashboard. It's a health dashboard, right? Your morning coffee view of what's up, what's down, how many tunnels, how many users are connected, how many BGP connections are up. If things are down, it'll tell you what's down. You can click it and it's interactive and it'll take you to different places of the UI so you can do troubleshooting. But it's a morning coffee view of the network. All right, well, we can tell you where all your data centers are deployed, give you a little geographic map of it, right? It's a dashboard. Everybody knows what a dashboard does. We also have the breakdown of how your gateways are deployed. What gateways are deployed, what types, transits versus spokes. If you had a VPN concentrator gateway, you would show up there. It would show you which regions they're deployed in, and then the size of the gateways, the distribution. Because you remember, you can change the size of the gateways when you're deploying them to meet certain requirements of throughput in your cloud. And we can support 70 plus gigs of throughput, of encrypted throughput within the cloud. It's pretty incredible. We can also see and gather all the network traffic data across your entire multi-cloud network. But that's not cool. Well, it is cool, but let me show you what's truly cool is topology, dynamic topology. Now, keep in mind, when you guys were deploying things on-prem, you probably used Visio or Lucidchart to keep track of what things have been deployed. And that's great because on-prem, it doesn't change that much. The cloud is different. The cloud is constantly changing. It's a super dynamic and versatile environment. And really anybody can log in and do what they want in the cloud. It's so easy to consume, right? So you need something that's dynamic to show you what's the current state of this environment. And so you can see here, this is what we built out together today. You can see it's showing you the EU West 1, EU West 2, and the West US 2 Azure environments. Now, everything is clustered to keep it clean, but I can uncluster stuff to show what's inside those VPCs and those VNets. All right, so I unclustered it, and you can see that I have that US West 2 workload there. I can see the subnets that have deployed, the gateways, the actual VPC information, and everything in here is interactive. I can click anything. So right there, I clicked that instance, and I'm gathering the metadata directly from the cloud provider and showing it to you in one place. So it's easy to do troubleshooting. You can come to this one place to gather any metadata you want. IP addresses, DNS information, region, instance IDs, latitude, longitude, anything we can pull from that cloud provider we're gonna show you here. But what's cool is that we're databasing all this. We can gather it all, and then you can do searching from it. So I'm gonna grab this IP, and I'm gonna search that IP, and you can see it popped up. Hey, that IP belongs to this resource. And it gives you a nice little thing here. You can filter it out to just see that one resource. But anything is filterable. Any metadata we gathered, you can do IP addresses, dotted decimal, regular expressions. You can even do regular expressions here, which is cool. I don't demonstrate that, but you could. If you guys know regular expressions, you can play with that here. And it'll give you a nice little output. So it's easy to do troubleshooting now, just quickly determine certain environments. What I'm doing now is I'm control click, like multiple select. I'm gonna select multiple things in here, and I'm gonna give it a tag, a custom tag. So I'm gonna call it, I think, EU Dana or something. Yeah, I call it EU Dana. This is a custom tag that I'm adding so that I can leverage this later on. When I come back another day, I can search my custom tag and it will only show me what I've tagged. All right, so EU-Dana. Now, everything I tagged is highlighted, and then you can filter that out. Why is this useful? Well, everybody might be troubleshooting different environments, or maybe you want to separate from a visibility perspective your credit card data environment from your dev environment, from your different workloads. So it's a really nice way to do troubleshooting and separate this and clean up the topology, okay? Now, on top of that, we can use this environment for visual troubleshooting. We can select a gateway, and then do ping and trace route from here. So you can select the source, select the destination, and do some ping and trace route. Right here, I'm pinging the internet from a gateway, and of course it's going to work because these gateways are reachable to the internet. So I'm checking that. If you want to do a source and destination, let's say you want to go from one VNet to a VPC across multi-cloud, and you want to check that connectivity, you can do it from here. You no longer have to have instances within those environments or access to instances to do that troubleshooting. As a network individual, you might not have access to those instances, right? So you want to be able to use your gateways, your network constructs to do ping and trace route. In the near future, we're going to add packet capture. We already have packet capture in the UI, but from here, we're going to add packet cap. We'll add things like performance testing and stuff like that. All right, what I'm showing you now is that you can select any one of these green links, which are Aviatrix encrypted peerings, transit peerings, VPC to VPC, VPC to transit, transit to transit, and we can run latency checks. Remember, we're building an overlay, and so we can gather a lot of data that you can't see normally. And so we're going to build, I'm basically selecting a bunch of these transits, enabling latency monitor, and on the top, I can click latency monitor, and it will start to map this latency out for you end to end. This is brilliant. For a networking individual, this is brilliant because you might have the app owner telling you, hey, my app is performing poorly. And so you can quickly see end to end what's the latency to see if it's within spec of that app. Okay, and in the future, in the near future, and we deploy like new code on CoPilot every 2 or 3 weeks. We're going to support thresholds, so you can set a custom threshold, and it'll alert you if your cross-cloud threshold reaches a certain thing and whatnot. Now, this whole topology is manipulable. You can mess with the physics. I like playing with it because it's kind of fun, and you can create your custom topology. So you could turn off the physics and the pinning, and then go build your own topology with these things that it dynamically gathered, and then you can save it. Okay, so I'm going to save it as Dana's top topology. I can come back another day, and I can load that layout. And everybody can have their own layout. Maybe one of your colleagues only plays with a certain environment. He can have his own layout, and you can have your own layout. All right, pretty brilliant. All right, let's move on to flow. You guys all know what NetFlow is, right? And you know that native cloud service providers provide you little to no flow data. It's very basic and pretty much useless from a networking guy or gal's perspective. But what we're doing is providing you NetFlow v9 analytics and data, because we have gateways in the path of traffic. So we can gather all that information. We can tell you top talking ports and protocols, the amount of throughput and data that's been pushed on every source destination protocol or IP address. And what's cool about this is that everything is interactive. I can click like this IP address here. So I click that IP, and it dynamically created a filter. And everything else downstream now is based off of that source IP, right? How brilliant is that? I can pick the top talker and see who's it talking to, what ports and protocols is it talking to. All right, what I'm going to show you next is you can create custom filters, not just clicking things and creating the filters. You can select up to 80 different types of filters and create a custom complex filter set. So let's say you know exactly what to filter on to see your app that's in the cloud. You can build that filter. So I'm going to build this one, and I picked some random internet-based IPs because I couldn't remember internally what IPs I was using at that time. So I picked 4.2.2.2. That was my destination. I'm going to pick a source IP. Remember, this is not just IPs. There's 80 different things you can filter and use from NetFlow data. I'm going to do a source destination because that's basic, right? Super simple. And then I can hit apply filter. Now, of course, I didn't have any traffic, so it's not showing you anything there. But if you did, it would show you that specific filtered traffic. Now, what's cool is I can save this filter group. I can call it Dana's app, okay? And then I can come back another day and quickly filter on that app. If you're curious, what's this app doing? I can quickly load that Dana's filter app, bam, it's there. It has all the information. It's filtering things for you based on that app. And you can create custom complex filters and save them, load them whenever you want to do troubleshooting. This is powerful. This is unheard of in the cloud. And all this is cloud focused, cloud native. It's designed to gather the cloud environment, okay? So another cool thing, oh, I went too quick there. I'm talking too much. Let me back up 1 second because I want to show you what I was doing, which is pretty cool. What I'm doing here, let me go forward a little bit. Okay, what I'm going to do now is I'm going to filter based off tag. Remember earlier in the topology section, I created that EU Dana tag and I tagged some instances, some components, some constructs. Well, what I can do is filter based off tag. and see only the information, the NetFlow information of the instances and the stuff that I tagged. Pretty powerful. You can go back in time, last hour, last day. This is historical. You can select a custom period of time based on a calendar in here, right? This is a really fantastic solution for visibility. Now, all these filters are carried over to every tab in CoPilot. I haven't carried over the filter, but you can do that. This is the NetFlow network analytics tab. So it's giving you information on talkers of source information, destination address, IP address, total bandwidth utilization of those apps, or the information that it's pulling. You guys have all seen this before. This is straightforward NetFlow network analytics. But what's even cooler is geolocation. So we can map out, if you're an entity that talks with a lot of public organizations, we can start to map out via geolocation who's talking to who. You can see my demo environment is talking to a lot of stuff. And a lot of that is not by design, right? I'm actually just being port scanned by different countries, and they're probably looking for vulnerabilities. And so you can see cities and countries, and you can see the hotspots. The hotter the environment, the more data is being pushed in and out of that environment, okay? It looks like Florida's got a lot of stuff going on. Or maybe this is a map of COVID. I don't know. But no, I'm just joking. This is all NetFlow data. So you can also see this information on a Sankey chart. Sankey charts are really nice ways to see source destination flows, disbursement of those flows, and see who's talking to who and what's the breakdown of every flow. And you can see kind of a percentage of that breakdown. Now, if you want to gather the raw records from CoPilot, we can show all of that, up to 80 different fields of data that you can gather, and you can edit here, and you can search through, and you can create filters on and have for your own purposes. Now, we're not going to leave you blindfolded. You're throwing your packets on our data plane, on the gateways that you spun up. So we want to give you visibility into what's the performance of each of these gateways. What's the free memory utilization, the CPU utilization, the disk utilization, the transfer rate in and out of those gateways. All right, so we're not going to leave you with any blinders, okay? Pretty cool, right? So that was CoPilot visibility. Now, there's one more thing that I have time to show you, and that I didn't record, but I thought, this would be cool to show anyways. And I'll show it to you pretty much live. So remember, our controller is gathering all sorts of information from your constructs, from your native cloud environment. It's looking at routing tables, it's looking at VPC routes, UDRs, TGW attachments, it's looking at instances, security groups, network ACLs, load balancers, it's looking at all sorts of stuff. And so it's gathering all that in a database. So why not leverage that database for troubleshooting? And so we have this feature called Flight Path. So let's go under Troubleshoot, and you click Flight Path. And what Flight Path lets you do is pick a source and destination instance that you want to test connectivity to and from. All right. So this is cross cloud too. You can do cross region or cross cloud, but I'm going to do a test from my region, the EU, was it EU1, in that VPC that I created with you guys right here. I'm going to query the resources. I'm going to go all the way to Azure, and I'm going to test the connectivity into West US2, where my workload lives that we built together, query the resource. I'm going to select this guy and that guy. So the source and destination, we want to test this on the private side connectivity. You can do public or private, and whatever port and protocol you want. I'm going to do 443 in TCP and hit a flight path test. Now, this takes a little bit of time. It takes about like 15 seconds. I don't want to wait 15 seconds. I'm lazy. So I have already this pre-deployed out for you. So you can see the source. It went through and checked security groups, route tables. It even tells you what entry it hit in each of these constructs. You can click this and it will open the construct link. It'll take you directly there. Oops. It'll take you directly. Oh, now it refreshed my screen. I should have done this live, right? But anyway, so what it's going to do is it's going to check all the constructs for you end to end to make sure that everything passes the check, right? The route table was correct. It had a route entry, and the next hop was the ENI of the gateway, and that was active and not black holed. It checked the network ACL. It checked the spoke gateway route table, the Aviatrix Transit gateway route table, and then it goes across the transit and it hits Azure. And when it hit Azure, it failed. It failed on the Azure Network Security Group. And why did it fail? Well, I don't have a rule entry in there for TCP port 443. I purposely didn't add it there so I would get a fail, right? But everything else passes. If you scroll down, you get a little bit of an analysis output. You can see it could not find a rule in the inbound security group of the destination to allow 10.193.106.250, right? So imagine this takes, 15, 20 seconds or something to give you the answer as to why you can't get from source to destination versus you having to log in and click every construct and every hop by hop and figure out, okay, how does Azure work versus AWS and what constructs is it going to hit and where's my entries and where is it not reaching the, the destination. It figures it all for you. All right. That's really the end of demo day today. Now we have some Q&A. I'm sure my buddies have been answering a lot of these questions, and I want to go through, I want to do one or two of these. Let's see. One question here. One question was asked, so are all those Azure VNets and AWS VPCs created earlier, or were they added by Aviatrix? Now, we can support either ways. You can actually go and create VPCs under here, the VPC creation mechanism. We can add a new VPC, and you can specify if it's a VNet, a G Cloud instance, whatever you want. You can build your VPCs from here. Now, that's kind of good for somebody who's like basic, but most people would want to create this via automation and create your VPCs behind the scenes and just have the Aviatrix controller learn about them, and then you can leverage them in drop downs like I showed you when we were building the multi-cloud network environment. But both ways are supported. We're not going to stop you either way. We're a very flexible solution. Okay, so we've had a ton of Q&A. I can't believe how much there is. It's unbelievable. And we have a ton of people who joined us. And this has been a fantastic session. I really want to thank you all for joining me. If you have any additional questions, please feel free to reach out to us at info@aviatrix.com, and we'll get you set up with a solutions architect, and you can ask any question you want. We'll answer them. We can jump onto Zooms with you and do architectural sessions. And if you want to learn more about Aviatrix, go to the events page. Go learn about it by watching this stuff, or YouTube. We have tons on YouTube. If you want to get certified in Aviatrix, we have a certification process. It's called the ACE certification. If you go to aviatrix.com/ACE, it'll take you to that page, and you can go in here and there's an instructor-led page, or there's a self-paced if you want to do it via self-paced, and you can go through the associate and the professional levels, and you can learn how to deploy and troubleshoot the Aviatrix cloud networking platform. Thank you very much for joining me today, and I hope to talk to you guys soon.